the word trait comes into your mind, what is the initial thing that strikes your mind? Trait means a certain kind of behavior, right? Now, traits are actually a particular kind of implementation that you can create in order to be used in different struct implementation. That means, as you have done right now, creating a generic function would save you more time and also would save you more space in creating a single function that can handle different scenarios. Traits are used to create a common set of functions that can be implemented by different structs. Okay. So traits are used to define a shared behavior in an abstract way. You might have seen such scenarios or such implementations in different languages like Java, where you might be using interfaces or abstract classes, etc., where you want to have a particular set of functionalities that can be then extended to different class. Okay. Now, the idea is you create a pub trait summary where you are actually going to pass a function, summarize, and self string. Now I have only defined the I have only declared the function here. Now I can use this trait to implement a function for any different data type or any different struct that is required. Okay. Now imagine you have a certain set of functions or characteristics for a particular entity, and you want to also implement this to the other entity. Let's consider a simple example. Let's say you have two actors or two people in the environment that we consider. It could be a teacher and it could be a student. Okay. Now, in order to retrieve their name and details, why we want to write two functions? Like say there will be a similar data including the name, age, address, etc., right? So I can write an IMPL student and then write a function retrieve details and then type the definition like return student dot name dot details dot everything. And I can do the same with the teacher also. I can create the teacher's IMPL and then define a function, return details. And then why doing all these things when you can actually put the return details into a particular uh, trait and then implement that trait for the particular class. So that what happens is you can bring all these related functions in an encapsulated way called a trait, and you can implement the trait for different structs. So that is the general idea of using trait. Now we will go into see how we will work with different kinds of traits. Okay. So yeah, here we only declare. If you are familiar with Java, then you might got the idea of okay interfaces. Similar implementation would be traits. Okay. Here we declare a trait name summary and with a method declaration. So we only declare because we want to have different implementations for the same function in different structures. Let's say in case of teachers, you might want to have some more details rather than the students, or vice versa. So you can use the same function definition, but you can add different things when you implement it for the different entity. Okay. Now this is how it can be implemented for any strike. I think we, yeah. So usually now, as you can see in the screen, there is a lib.rs. Now, what is lib.rs? This might be the first time you will be hearing a lib.rs. So lib.rs means a library, a file that you would use to create your definitions and all those things, so that this particular file can then be used as a package in the required main.rs. Okay. So the idea is to create all the definitions in a file and then use it in the main.rs, so that your main.rs function would be neat. Okay. So it would only contain the required definitions. It's like the use statement. You can use the use statement to access everything that has been written on the lib file. The lib files, mostly when we talk about different kinds of IMPL, creating structs, we actually do not want to use or create all these things into the main function or the main file. We will just create subfiles. We will implement them in the subfiles, and then we will call and use them only in the main.rs, and that is the neat way of programming. Okay, so this is how we actually do. We do abstract news article. We are creating a simple struct. And then we are going to IMPL the summary for news article. As you see, I have created a trait summary. Now IMPL summary for news article. What I am doing, I'm just FN summarize and self string. So now I have given a definition to the declaration this summarize, right? So summarize has been a declaration in the trait summary. So when I am implementing it in the news article struct, I'm actually giving it a particular definition that is only staying inside this IMPL for news article. Now you can use the summarize function implementation in the other struct also. If you want to take another example for tweet, you can also implement it for tweet. Now the idea is the question is why we need to actually do such kind of like why are we even creating a trait at the end of the day, because we anyway we need to implement it for each of the struct, right? So the idea is to group things of similar patterns. And the question would be like, why you want to uh, like classify these implementations into a particular file, and the other kind of definitions into a different file, and why only the execution part is placed in the main file. So it's like we can categorize, and it is easy to work with, it's easy to debug, and it is easy to change a common characteristic or behavior because you only want to change it in a single implementation if required. Okay, so that is the idea of having traits. I think you got an idea of traits. Now that is it. Now we have implemented the trait on news article, and if you see, both of them have a different uh, definition. Here what we do is format is being used in order to combine self.headline, self.author, and self.location. Whereas here, in case of tweet, what we do is we are formatting and combining a self.username and self.content only. So the same trait function is being used or given two different implementations in two different places. Okay. This is now while you want to actually call or use these kinds of implementations in the main, you will use the use command to actually get them into the main.rs. Okay, and then we create a tweet. This tweet struct and username is being given, content is being added, and we give some of the details that needs to be placed inside the struct, and then you can use the tweet dot summarize. So this is how you would call the function. It is similar to what we have discussed in the last session. Once you have defined a function, now it is very easy for us to call it in the main function. And keep the idea in your mind that when we want to define or specify the structs, their implementations, the traits regarding a particular struct, we would always try to categorize all these things into a particular file called lib.rs. So when you scale your code, or when you are actually working with your code, then obviously you'd be seeing these kind of implementations. I hope so. Now, see, whenever we have a trait, you can also have a default implementation. So those who know Java, they will think, okay, I've got the idea. The basic idea is this is interface, and you can have an implementation, or you do not want an implementation. So default implementation is just the idea that you can add a default implementation if required. See, initially when we were using the trait, in the previous example, we never gave a particular definition to the trait, right? We never gave a definition to the trait. We only defined it when we actually took an IMPL from the given struct into two different implementations. But here, what if we need to add a default implementation? What if for both the different structs, when you implement this function, the output needs to be the same? Okay, let's say let's say I'm going to create a function, and I have two structs, student and teacher, and then I want to create a function greet. So according to the time, let's say the parameter is time, and if the time is between 6 or 9 to 12, then I want to send a message, greetings like good morning. and afternoon I want to do the same, and in the evening and night also I want to do the same. Now, does this function implementation differ for both student and teacher? It's the same, right? So the idea is simple. If you want to give a default implementation and you do not want to change it or do not want to implement it differently for each of the structs, then you can include it as a default implementation while you define the trait function. Okay, so you can also add a default definition to the function that is placed in the trait. I think the idea was clear when I took the example, and when you start implementing, you will get an idea of why using traits, and so it's all about practice, and we move on to more and more practice. You'll get an idea. So this is the basic idea. Like, you can define and you can add a default implementation as well.